Okay, welcome to flip teaching and my awesome videos. I'll make lots of mistakes and that's part of the fun, so let's just get started. We're going to start talking about relations and functions. Probably haven't heard functions, but you've been working with them, same with relations, and I think it's easier to give an example really. So in this case, let's talk about a relation. A relation is between x and y usually when we talking about coordinate planes, things like that. So we're usually talking about how do x and y relate, okay? So that's a relation, okay? And there's lots of different ways to represent these. So there's different ways to represent a relation. I'm going to talk about 4 of them. Number 1 is an ordered pair. We all know what that is, x comma y. See if I can get all 4 across here. And, that just looks like 1, negative 2, 3, comma 5, maybe negative 4, comma 7 or something. Okay, so these are all representing a relation. When x is 1, y is a negative 2. When x is 3, y is a 5. So that's a relation between x and y, and we're very familiar with those. And I can write down this list of ordered pairs. Another way to do it, though, is with a table. Okay, and again, something we're very familiar with. We make an x and a y table. I think I should go to a different color. And we can do the same relation shown in a table, 1, negative 2, 3, 5, negative 4, 7. So nothing earth-shattering here, we're just getting some vocabulary down. And we want to make sure that we're able to go back and forth between these multiple representation. That's the new buzzword now in teaching math, this multiple representations. So let's do another representation of a relation besides the table and the ordered pair. We can represent this relation with a graph. And a graph would, of course, have 2 axes. We typically, horizontal axis is the x, the vertical axis is the y. We will label these with quadrants when both x and y are positive. That's your first quadrant. So you have plus, comma, plus, right? In the second quadrant, you have x is negative and y is positive. And in the third quadrant, you have both the x and the y are negative. And in the fourth quadrant, you have your x is positive, but your y is negative. Okay, so we want to just remember how we do our graphing on this coordinate system, and we could graph those same points on here, and hopefully you're able to do that still. I'll do it real quickly. 1, negative 2 would be down here, 3, 5, somewhere up here. We have negative 4, 7, so I have to go negative 4 and up 7. It's going to be way up there somewhere. Okay, so we'll be doing some graphing, but I trust that you remember how to do that. Then finally, we want to talk about this 4th representation called mapping, where you just basically have this blob for input. So here's your input, and we have a set. And in that set for the input we have some numbers, 1, 4, we were doing 1, 3, and negative 4. And then we have a set that contains the output, and that set contains some numbers, and I'll just mix it up to show you what you can do. Maybe I wrote it this way just to be different. And we map how the input relates to the output. When x is 1, y is negative 2, so you map it with an arrow. When x is 3, y is 5, so it doesn't have to line up side by side like in ordered pairs, and negative 4 and 7. Okay, so that would be a mapping. And here I wanted to get some very important vocabulary. I can't stress to you how important this vocabulary is. It's something we all complain about, that we don't seem to appreciate the value of this vocabulary. So here's something really important. let's see, maybe I'll switch colors. Okay. When we're talking about mapping input and output and all these other representations, we have what's called domain and range. And so when you're mapping, the input is called the domain and the output is called the range. And that's true for these other representations as well. Typically x is the input, you give an x, find y, and y is the output. So we would say the same thing. All your x coordinates is your domain, and all your y coordinates is your range. So you can think about it as x and y, you can think about it as input and output. Alright, so that's relation. Let's go talk about functions as a subset of relations. Okay, so remember, domain, input, or all your x coordinates, and range, output, or all your y coordinates. So we want to talk about functions. Functions start with a relation, but only some relations are functions, okay? And here's the official definition, and then we'll talk about how we're going to talk about it and use it. So, let me see if I can type this up. Okay, if each element of the domain is paired with exactly one element of the range, then that relation is a function. So that's kind of a mouthful, and this is the way I think about it. I say, for every x, there is one y. And I mean exactly one y. And you'll remember when we say exactly one, we mean one in only one. So it can't be 0, it can't be any other number, it has to be a 1. Okay, so this is the way I think about it. For every x, there has to be just one y. Okay, so we could add the just or the exactly or anything like that. Okay, and now you want to be really careful going back to some of our vocabulary. We're not necessarily saying the converse is true. This is not a one-to-one, okay? You have to be careful. It's for every x, there's only one y, okay? So make sure you're going in the correct direction when you think about this. So let's try some of these things for yourself, and I want you to try these problems. Okay, so you try this one. I'm going to give you a relation, and you're going to answer 3 questions. You're going to state the domain. You're going to state the range. And then you're going to tell us, is it a function or not? Or maybe it's just a relation. Okay. So here's the relation I'm going to give you. I'm going to use ordered pairs. 10, 3, 6, -2, 7, 4, and 6, -9. Okay, so those are my 4 ordered pairs in this relation. I'm going to pause it, you're going to think about it, you're going to write down the answers, and turn it back on, and I'll show you my answers. Okay, so I'm showing you my answers here, so hopefully you had time to finish, you paused it. You should have written down this domain is the set of numbers 10, 6, and 7. I don't have to write the 6 twice, even though it appeared twice. I state the range, and it is the set of numbers 3, -2, 4, and -9. I'm just pulling off every one of those y values. And then I said, no, it is not a function, because I looked and I said, wow, when x was 6, y could be either a -2 or a -9. So that does not satisfy this requirement for every x, there's just one y. So I'm going to say, no, it's not a function. And we're done with that question. Let's try some more on the next page. Okay, here's one for you to try. Pause it, because in a minute I'm going to put up my answers. I want us to compare. Okay, I came up with a domain, -3, 0, 1, and 2, to range -7, -5, 3, and 4. I put them in ascending order to make my set a little prettier. And yes, it's a function. For every x, there is only one y. And one of your tip-offs here is that, you know, I've never listed an x twice, so there's no chance for it to have a second y. Does that make sense? So that's a tip-off that, of course, it's going to be a function. Let's try another one. Okay, try this one, same 3 questions, and give it a pause. Okay, you can see my domains and ranges are pretty straightforward. This is not a function. No, it's not a function. because when x is 2, y could be either 5 or 10. So that's the reason why. Don't get confused by the fact that the range, this 2 in the range set, has 2 possible inputs. That would be a converse, and we're not talking about that. Remember, we have to go x maps to y, and how is that going? Okay, try this one, same 3 questions, so give it a pause. And I simply wrote out my domain and range, as you can see, for those whole number values. We're sticking to the easy stuff right here because it's pretty hard to draw on this thing. And no, it's not a function, because you can see when x is 1, you have the 2 choices for y. Y could be a 0 or it could be a 2, so you just, knowing x is not enough to know which y it is. Okay, I have one more for you. And just go ahead and tell me whether or not you think this is a function or not. So pause it if you need to think about it for a minute. And the answer is yes, it is a function, okay? So again, it's one of those, don't be confused that it's not the converse. So when x is 0, you know y is 3. No ambiguity. Given an x, you'll be able to get to a single y. Okay? So that's all we needed to know, and that makes it a function. See you in class.